welcome. In this session today we are going to look at a very interesting aspect of or interesting application in which database technologies are used, namely the field of data mining and knowledge discovery. In fact, in recent years data mining has become an extremely a field that's eliciting an extremely large amount of interest, not just from researchers but also from commercial domain. I mean the commercial utility of data mining is probably of more interest than or at least as much interest as the research interest that lies in data mining. And in addition to commercial interest, there is also a number of public debates that data mining has started, which range from topics like legalities and ethics and the rights to certain information and the rights to non-disclosure of information or the rights to privacy and so on and so forth. So data mining actually is in some sense has opened a Pandora's box in and it's only time will tell whether the technology has been on an overall sense completely beneficial or destructive in nature. But then there's nothing beneficial or destructive about technology per se. It's how we use it, how we use technology, which is what matters. So anyway, in this session we shall be concentrating mostly on the technical aspects of data mining, obviously, and we shall look at the basic algorithms and concepts that make up data mining, and what exactly is meant by data mining, and how does it differ from the traditional operations of databases or traditional way in which databases are used. So the overview of this set of two sessions would be as follows. Let us first motivate the need for data mining, that is why data mining, and what are some of the basic underlying concepts in data mining, what are the building blocks of data mining concepts. Then we look at data mining algorithms and several classes of these data mining algorithms. We will start with tabular mining as in mining relational tables, and we will look at classification and clustering approaches, and we will also look at mining of other kinds of data like sequence data mining or mining of streaming data and so on. And data warehousing concepts would be covered as a different session altogether. First of all, why data mining? From a managerial perspective, let's first look at what data mining has for the commercial world first, before we go into looking at the technical aspects of data mining. If you were to let us say give an internet search or talk to a manager, let us say about why he or she would invest in data mining, you would encounter a variety of answers. One would say something like strategic decision making, that is I look for some kinds of some ways or some patterns and or mine for certain nuggets of knowledge to understand something about strategic decision making, or to help me in strategic decision making. Somebody would say, well, it is very useful for something called wealth generation, also although there is no precise definition of the term wealth generation, and you would say that, oh, data mining would help me in understanding or making the right decisions that can help me increase my financial portfolio or whatever. Somebody would say, well, I would use data mining for analyzing trends, analyzing how my customers behave, or analyzing how a particular market is behaving, and so on and so forth. And more recently, data mining has been used extensively for security purposes, especially mining network logs or network streaming data in order to look for abnormal behavioral patterns or patterns that might be potentially linked to abnormal activity in the network or in the system and so on. So security is now a relatively recent and a very important application area of data mining. So what is this data mining all about, and why is this so controversial, and why is it so interesting from a technical perspective at the same time? Data mining is the generic term used to look for hidden patterns in data or hidden patterns and trends in data that are not immediately apparent by just summarizing the data. So if I want to look for certain patterns, let us say if I have a set of all students and their grades, if I want to look for certain patterns on how are the students performing over time, or what is the is there some kind of a relation between subject A and subject B? I mean, if a student does well in subject A, he or she does badly in subject B, or so on and so forth. Such things cannot be discovered by just aggregating the data, by just saying what is the average or what is the summation or whatever. And besides, such things also cannot be discovered by I mean, such things in a sense cannot be within quotes discovered if we have to give queries that finds out these aggregations. That is, if we already knew what it is that we are looking for, then it's not a hidden pattern anymore. We know that such a pattern exists. That is, students performing in subject A will not perform well in subject B. We know that such a correlation exists, and there's nothing hidden in the pattern anyway. So data mining essentially has no query. That is, if we are performing a data mining on a database, we do not talk of any data mining query. In fact, it is the mining algorithm that should give us something which we don't know. Okay. Now, how do we say something which we don't know, which is putting it in a very broad sense? I mean, which is making things so vague. So data mining is actually controlled by what are called as interestingness criteria, and we just specify to the database that this is what we understand by an interesting pattern. Let us say correlation between performance in subject A and subject B, or some kinds of trends over a period of time. This is what is interesting for us. Now find me something, or find me everything which I don't know about, or which are interesting according to this criteria.